This is section 12.5, volume of pyramids and cones. And to start off with, we're going to do a review of finding area of regular polygons. And to do that, we're going to draw in a couple of segments, draw in a segment to a couple of consecutive vertices, also draw in an apothem. Since each side of the regular hexagon is 10, that means that this little length down here at the bottom is 5. Calculate the measurement of each angle in the regular hexagon, and that comes out to 120 degrees, which means that when you draw in one of these radii, it creates a 60-degree angle. Next up, using this gray right triangle, we can find the length of x using trig. So we could say specifically that the tangent of 60 degrees is equal to opposite over adjacent. Multiply both sides by 5. And there is the exact length of x. Now the reason why that's significant is because next thing we're going to do is find the area of this entire yellow triangle. So kind of block this little part off, and I'll say the area of that triangle is equal to 1/2 times the base. The base of this whole yellow triangle is 10 times the height, which we just found, that's that x value, that's 5 times the tangent of 60. And then before I go to the calculator and start working with decimals, I'm going to multiply all these rational numbers out front. 1/2 times 10 times 5. So the product of all of those comes out to 25, still with the tangent of 60 after it. That's the area of this one yellow triangle. But because there are 6 sides in this regular hexagon, it means that there's 6 congruent triangles, all of the same size. So then the area of this hexagon is 6 times that 25 tangent of 60. And now if you multiply all of that together, you get an approximate answer of 259.81 units squared. Going back a step, 6 times 25 is 150. So a good exact answer would have been this. And then here is our approximate answer. We want to find the area of this regular pentagon with each side equal to 6. So we'll draw in a couple of radii, also draw in the apothem. That makes this little length equal to 3. Each angle in the regular pentagon is 108, which means that this angle is 54 degrees. We'll call that x, that apothem. Once again, it's the tangent function. The tangent of 54 is opposite over adjacent. Multiply both sides by 3. And that's the length of x. So then, the area of this yellow triangle is equal to 1/2 times the base of 6 times the apothem, which was 3 tangent of 54. And then multiplying all that together, we get 9 times the tangent of 54 is equal to the area of that one triangle. So as we go into the area of the entire pentagon then, we have to recognize that since there's 5 sides in the pentagon, there are 5 of these congruent yellow triangles in there. So multiply that area by 5. 5 times 9 is 45. So the exact area of this pentagon is 45 times the tangent of 54. And that gives us approximately then 61.94 units squared. The volume of a pyramid is 1/3 the area of the base times the height, and the volume of a cone is 1/3 pi r squared times the height. Pyramid is 1/3 the volume of a prism. The cone is 1/3 the volume of a cylinder. So in this example, we have a pentagonal pyramid. It is a regular pentagon base. The height is 12. So we could say that the volume is 1/3 area of the base, which we don't know yet, times the height of 12. Now we just need to find the area of that regular pentagon base, plug it in, and we can get the volume for the shape. Draw out that regular pentagon. Each side of the pentagon is 14. So like we've done on previous problems, we're going to draw in a few segments. Draw in a segment to 2 consecutive vertices. Also draw in an apothem. Since each side of the regular pentagon is 14, it means this little length across the bottom here is just 7. It's half of that. In a regular pentagon, we've done this work before. Each angle is 108 degrees. So this angle then is half of that, or 54 degrees. we want to find the length of this apothem, which we'll call x. We'll do trig on it, again, just like we did before. The tangent function is what brings that all together. The tangent of 54 is opposite over adjacent. Multiply both sides by 7, and that's the length of x. That x is then going to help us find the area of this yellow triangle down here at the bottom. The area of that triangle is 1/2 times the base of 14 times the height of that triangle, which is 7 times the tangent of 54. Multiply all of those coefficients out front, 1/2 times 14 times 7, and the area of that triangle then is 49 times the tangent of 54, still as an exact value. Block that off, because we want the area of the pentagon. The pentagon has 5 congruent triangles that all have the same area as that one yellow one. So the area of the pentagon is 5 times that, 5 times 49 tan 54. And if you multiply that out, that's 245 times the tangent of 54. That's the area of the pentagon. That goes on this blank up here. And now we're to the point where we can multiply everything together. And the volume is approximately 1,348.85 units cubed. Here's our next example. We want to know the volume of this cone. Volume of a cone is 1/3 pi r squared times the height. 1/3 pi times the radius of 5 squared times the height, which is not 13. 13 is actually the slant height. But if we draw in the perpendicular heights and also draw in a radius, those are going to be perpendicular to each other. And the cross section we're looking at right here is a right triangle. So if I were to draw out that right triangle, I would see that we have a leg of 5, a hypotenuse of 13, another leg of h. So if you use Pythagorean theorem on that, 5 squared plus h squared is equal to 13 squared. You'd get that height to be equal to 12. 12 is the height of this cone. So plug it in for that little h for the height of this cone. And then if you multiplied all these coefficients, 1/3 times 5 squared times 12, that would actually give you 100 pi. So still no decimal. We still have it as an exact by multiplying all those rational numbers together. And then 100 times pi will give you your approximate answer then of 314.16 units cubed. Next up, we want to find the volume of this square pyramid. It is a square base. So it's 1/3 the area of the base times the height. The height is that red dotted segment, that's 8. We want to find the area of this base though. It is a square. Each side of the square is equal to 10. The way we find the area of a square is take the length of one side and square it. So the area of the square is 100. Multiply all this together and we get about 266.67, or we could have said exactly 266 2/3 units cubed. Either one of those answers we would accept.